More than 200 years ago, Americans with virtually no scientific knowledge sought ways to tame and put to use a continent that seemed to stretch endlessly before them. Today many American scientists believe they possess the knowledge to accomplish virtually anything, yet they are achieving less and less that actually benefits humanity. The history deals with how we have built or made certain kinds of things and how we have decided what to build or make. We can now build machines that will do almost everything for us, from cooling a room in the heat of summer to blowing up the world. We can arrange these devices in technical systems that in their operation profoundly modify and sometimes take the place of our natural environment. The workings of these systems, if insufficiently controlled, certainly contaminate and may in time exhaust significant resources of nature. The task at hand is to design the pieces of machinery and the structure of the enclosing systems to prevent such things from happening. It is to design and control things so that the artificial surroundings we create for ourselves will serve our interests better than the supplanted natural environment did. How to give these products an appropriate order, meaning, how to organize a technological world we can live in, is now the great question. The criteria for such design and control cannot be established by a search for the maximum potential in each particular machine system. The criteria must derive from some general scheme that all the parts and pieces can fit into. Such a scheme cannot be based only on our knowledge of what machines can be built to do almost anything. It has to be grounded in the sense of ourselves as the governing reference point. The controlling factor in the design problem is what we take the human condition to be. If we are to control the technological world we are building, we must first require ourselves to understand and respect the fundamental organization of our being in order to build a technological firmament that will really fit us. At the center of all engineering works lies the problem of translating knowledge into practice, the complex process of converting the abstract into a real and tangible work. Refinement of technique sometimes involves dramatic improvements in the state of art, but fundamental advances derive only from increases in the amount of information available. Sometimes these increases are produced by the searches of those who simply want to know more, and sometimes by those who force the search because they want to do something better, or different. The Romans built a remarkable set of structures including roads, aqueducts, temples, arenas, mine shafts, sewage disposals, bridges and municipal waterworks. In the course of this construction they learned to make and use a varied set of instruments such as pulleys, pumps, hoists, levels, cranes, hydraulic cement, metal trusses and even rivets. In their greatest period they built great structures from Asia Minor to the British Isles. Some of these still stand in distinctive grandeur as monuments to the genius of their creators. Marcus Vitruvius Pollio, a Roman architect and engineer, who lived in the time of Caesar Augustus, published a book called De Architectura Libra Decim. This work contains interesting summaries of the author's explanations of what he had learned on the job. The volume became a textbook on Roman engineering. 1500 years later, Bramante, Michelangelo, Palladio and other great builders of the Renaissance took Vitruvius as their chief authority. What the men of the Renaissance learned from De Architectura passed on to those who came after them. The Roman record demonstrates how much can be learned from experience and doing the work. Practice, supported only by the knowledge obtained from practice, provides invaluable insights. The Romans cared little, in fact, for the general implications of their work. They rarely sought the reasons for things or tried to build a sustaining structure of theory around what they were doing. The same was true of those who followed them for many years. So with a fixed set of resources and a stable body of procedures, the art remained, for a long time, in a fairly steady state. It was only in the early 17th century that men working with these same materials and forces began to feel the need to extend what Francis Bacon called useful knowledge about the natural world. Then things began to happen. The history of Western culture, or a great part of it, can be written simply as a search for further information. What made men different from, and indeed superior to, all other living things was the ability to acquire and process information. For a long time, this restless search for further information rested primarily on speculation about the biggest questions of life, such as the nature of reality and the meaning of existence. It had little to do with simplifying the day's work. The Greeks introduced an almost fatal division between the head and the hands. Thinking, an ennobled exercise, could, in fact, stand above, beyond, and apart from operations. This separation was for long, and to some extent still is, a source of mischief both in the way we seek to educate and conduct our operations. Somewhere near the end of the 16th century, things began to change. Many causes and many minds contributed to this gradual shift in intellectual affairs. Throughout the 17th century, there were tedious and painful efforts to connect one freshly discovered thing with another. Along the way, as recently acquired information began to displace older assumptions or explanations taken on faith, there were painful and dislocating debates over the structure of the universe, the nature of reality, and the meaning of existence. The life of the mind, oscillating in these years between polar differences, the ideal and the useful, things subject to the senses, was vivid, exciting, and at times very confusing. In the Novum Organum, in 1620, Francis Bacon gave his fullest statement of the need to search for that practical knowledge which could be applied to relieve and benefit the condition of men. The connections between new evidence, evolving ideas and subsequent action, physical labor, intuitive perceptions of countless builders, the weight of accumulating experience, the play of intellectual forces, refining methods of investigation, led humanity to steadily increase their knowledge and understanding of the world and apply what they had learned to modify the stern conditions of the world. Men have come almost to the fulfilling today of the Socratic objective. They know enough to enter the companion of the gods and sit with them in authority. This point achieved, it now turns out that knowledge is only one part of power. The other part is an understanding of how to use it, and in this area men still fall short of the divine comprehension.